Hello students, this is Mahesh Javalkar from MARATHA POLYTECHNIC, and today I am posting my second video on the DCET questions for the subject Analog Electronic Circuits, in which I am going to cover today biasing and amplifiers, that is biasing of transistor BJT or transistor and amplifiers. Okay. So here the topic will be MCQs on analog electronic circuits, unit 2, where the name of the unit is transistor biasing and amplifiers. So let's start with the first question, which is used to establish a fixed level of current or voltage in a transistor. Okay, means what concept is used to establish a fixed level of current or voltage in a transistor. Now we know that whenever we want to operate a transistor, whenever we want to use a transistor in a particular region, okay, then we have to give an external DC voltages to the transistor. Okay. Now that application of external DC voltages so that the first junction and the second junction of NPN or PNP or transistor is properly biased, and then we can say that the transistor is operating in certain region depending upon the biasing. Okay, so that is application of DC voltage is what we give, and that is biasing. So here the answer A will be the right answer, biasing, which is used to establish a fixed level of current or voltage in a transistor. The answer is biasing of transistor. Okay. Then second question, what is the point of intersection of DC and AC load line called? Okay, so we have studied DC load line, that is the load line drawn on the output characteristics when there is no AC signal applied, and we have also seen AC load line, that is a load line drawn on the output or characteristics of a transistor when there is AC load applied. Okay, now, in that case, when these two lines intersect, that intersection point is called as operating point or Q point or quiescent point. So here you can see you are having a AC load line and you are having a DC load line. And then you can see the point of intersection, which is named as Q. Okay, so here you can see the point of intersection, which is named as Q. This is the point of intersection. It is named as Q. Okay, so this is your AC load line and this is your DC load line. Okay, so the point where both these load lines intersect is called as Q point or operating point or quiescent point. You can also call it as operating point or you can also call it as quiescent point. So here option A will be the right answer, that is operating point. What is the point of intersection of DC and AC load lines called? It is the operating point. What is the operating point in the characteristic curve called as? As I have told you earlier, operating point or Q point can also be called as quiescent point. Okay, so the option A will be the right answer here, quiescent point. Quiescent. Quiescent point is nothing but your operating point or Q point. Then next question will go. Oscillators operate on the principle of options are positive feedback, negative feedback, signal feed through, or attenuation. Okay, it is obviously positive feedback. Now, in positive feedback, there is a compromise of stability, but you can generate oscillations. Now, positive feedback means the feedback what you give from from output to input will help the input. It will be in phase with the input. It will aid the input. Okay. So if you see the theory behind it, an amplifier with positive feedback produces its output to be in phase with the input and increases the strength of the signal. Positive feedback is also called as degenerative feedback or direct feedback. This kind of feedback makes a feedback amplifier an oscillator. Okay. The use of a positive feedback results in a feedback amplifier having closed loop gain greater than the open loop gain. It results in instability. Instability. This is very important and operates as an oscillatory circuit. An oscillatory circuit provides a constantly varying amplified output signal of any desired frequency, whatever you tune for. Okay. So here you can see this is your amplifier here. So here you can see this is your main amplifier. Okay, so main amplifier, when the input signal goes to the output, there will be a phase shift of 180-degree. Okay, and then when it is given, that output is given through a feedback back to the input here, back to the input. This feedback network will give you another phase shift of 180 degree here. Okay, so 180 plus 180 will be 360 degrees. So whatever output of the feedback comes with the original input, it will come in phase. In phase. Okay, in phase means it is going to help, it is going to aid, it is going to go with the input. Okay, so that is why the gain will increase, instability problem will be there, but it can provide oscillations, it can provide oscillations. Okay, so here the answer will be positive feedback. Oscillators operate on the principle of positive feedback. Amplifiers operate with what type of feedback? Positive, negative, signal feed through or attenuation. Obviously, this you should not forget at all. It is negative feedback for amplifiers because positive feedback goes with oscillators and negative feedback goes with amplifiers. So in negative feedback, what is happening is when you connect the output to the input, it is going to give only a phase shift of 180 degree, which is provided by the amplifier circuit. The feedback circuit is not going to introduce any feedback. Okay, so the feedback, the total feedback to the input will be 180 degrees. So we say the feedback signal, whatever is coming, is opposing the original input signal. And that is why the gain might go down. The gain might go down, but it will be a stable circuit. Stability factor will be enhanced. Okay. So here you can see the theory of negative feedback. The feedback in which the feedback energy, that is either voltage or current, is out of phase with the input and thus opposes it, is called as negative feedback. In negative feedback, the amplifier introduces a phase shift of 180 degree into the circuit, while the feedback network is so designed that it produces no phase shift or zero phase shift. Thus, the resultant feedback voltage Vf is 180 degree out of phase with the input. Though the gain of negative feedback is reduced, there are many advantages of negative feedback, such as stability of gain is improved, reduction in distortion, reduction in noise, increase in input impedance, decrease in output impedance, increase in the range of uniform application. Okay? It is because of these advantages, negative feedback is frequently employed in amplifiers. Okay, so here the answer will be negative feedback. So here you can see the answer is negative feedback. Amplifiers operate with feedback which is negative. Then we'll go to see RC coupling is used for what type of amplification, whether it is voltage amplification, current amplification, signal amplification, or power amplification. Okay. Now, when we studied RC coupled amplifier, we studied it under the category of small signal amplifiers. And small signal amplifiers are one which concentrate on amplification of voltage. So here, option A, voltage, will be the right answer. So RC coupling is used for voltage amplification. Okay. Then we'll go to the next question. What circuit increases the peak-to-peak voltage, current, or power of a signal? If you are increasing, if you are enhancing, if you are strengthening the weak signal into strong, then it is called as an amplifier circuit. So here option C will be the right answer. Amplifier circuit increases the peak-to-peak voltage or current or power of the signal. So C, amplifier, will be the right answer. Okay. Then we'll go to the next question. Question number 28. Now this is on power amplifiers. Which amplifier whose output current flows for the entire cycle? Okay. Now the amplifier for which the output current flows for the entire cycle was our first definition what we studied in power amplifier, and that was the definition of class A power amplifier. Okay. Class A will give you the flow of output current for the entire cycle, that is 0 to 360 degree. Class B will give from 0 to 180 degree. Class C will give less than 180 degree. And class AB gives you between 180 and 360 degree. Okay. So these were the definitions what we had seen in a power amplifiers classification. Now this question, when it is asked which amplifier whose output current flows for the entire cycle, that is from 0 to 360 degree, then the answer will be class A. So option A will be the right answer here. Class A amplifier. Then a two-transistor class B power amplifier is commonly called as. So when we studied class B power amplifier and when we used two transistors, one transistor for each half cycle amplification, and we saw that each transistor was operating for 0 to 180 degree, that is a half cycle, then that arrangement of two transistors was called as push-pull amplifier. So here option A will be the right answer, which is called as push-pull amplifier. A two transistor class B power amplifier is commonly called as push-pull amplifier. So now here, students, we'll go to the next question, question number 30. If a transistor is operated in such a way that the output current flows for 160 degree of the input signal, then it is in dash operation. Now here, four options are given, that is class A, class C, class B, and class AB. If you see class A, here the output current will flow for 0 to 360 degree. Okay, if you see class C, it will be less than 180 degree. If you see class B, it will be 0 to 180 degree. Okay, and if you see class AB, it will be from 0 to 180 degree to 360 degree. Okay, so 180 to 360 degree. So that is the extension of class B. Okay, now in this question, we have asked that if a transistor is operated in such a way that the output current flows for only 160 degree, so it is less than 180 degree. So less than 180 degree is class C operation. So your option B will be the right answer, class C operation. So here you can see the answer B is the right answer. Then, which power amplifier has the highest collector efficiency? Okay. Now, if you see a comparison of all the power amplifiers, okay, then in that you can see the highest efficiency is with class C power amplifier. So here the option will be class C power amplifier. What type of coupling is generally used in power amplifiers? Okay, so in power amplifiers we don't want to short anything, we don't want to give anything direct, so there will be transformer coupling which is more beneficial with impedance matching also, and that is why the type of coupling used in power amplifiers will be transformer coupling. So here option A will be the right answer, transformer coupling. The maximum efficiency of a resistance loaded class A power amplifier. Resistance loaded, okay, that is a series fed, okay, resistance loaded class A power amplifier, not transformer coupled. We are speaking about resistance loaded. Now in resistance loaded class A power amplifier, the efficiency will be less, it will be around 25%. So option D will be the right answer, 25%. Then we'll go to the next question. The maximum efficiency of a transformer coupled class A power amplifier. Okay. Now in our last question, we saw a resistance loaded class A. Now in that it was 25%. Now when you use transformer coupled class A amplifier, the efficiency will improve, and that will be around 50%. So here option B will be the right answer. 50% will be the right answer. Then we'll go to the next question. Class dash power amplifier has the highest collector efficiency. So which has the highest collector efficiency? Okay. Options are C power amplifier, class A power amplifier, class B power amplifier, and class AB power amplifier. So here the answer will be class C power amplifier will have the highest collector efficiency. Then we'll go to the next question. Power amplifiers handle dash signals compared to voltage amplifiers. Okay. Now we know the basic definition. When we studied voltage amplifiers, it came under the category of small signal amplifier. When we study power amplifier, it comes under the category of large signal amplifier. So power amplifiers handle large signal compared to voltage amplifiers. So here option C will be the right answer, large signal. Okay. Then we'll go to the next question, question number 37. A class A power amplifier is sometimes called as dash amplifier. Options are symmetrical, single-ended, reciprocating, and differential. Okay. So out of this, the option B, single-ended, is the right answer. Okay. A class A power amplifier is sometimes called as single-ended. Okay. Series fed. Okay. So it is single-ended power amplifier. Okay. So class A power amplifier is sometimes called as single-ended. So yes, students, we'll go to the next question, question number 38. If a three-stage amplifier has individual stage gains of 10 decibel, 5 decibel, and 12 decibel, then the total gain in decibels is how much? Okay. Now we have shown here for a multi-stage amplifier. Okay. So for a multi-stage amplifier, the total gain will be given as So here, multi-stage amplifier, the total gain will be given as the product of individual gains. The product of individual gains. So here the product of individual gains means the individual gains was the first stage gain was 10 decibel, second stage gain was 5 decibel, and third stage gain was 12 decibel. So 10 into 5 is 50 into 12 is 600 decibels. Okay. So here the right answer will be 600 decibel. That is option A, 600 decibels. So here you can see if a three-stage amplifier has individual stage gains of 10 decibel, 5 decibel, and 12 decibels, then the total gain in decibels is given as 600 decibels. Okay. Then we'll go to the next question. The total gain of a multi-stage amplifier is less than the product of the gains of the individual stages. Now, practically, this can happen. The total gain is the less than the product of the gains of individual stages. Okay, that is because of the loading effect. That is because of the loading effect of the next stage. So, option B will be the right answer here. Loading effect of the next stage. Okay. Then we'll go to the next question. Gain of an amplifier usually expressed in decibels because, okay. Now here the reasons given are it is a small unit. Answer B is our calculation becomes easy. Answer C is human air response is logarithmic, and answer D is gain is reduced. So here out of these four answers, answer C will be the right answer where you say human air response is logarithmic, and because of that gain is expressed in decimals. Okay. So here option C will be the right answer. Human air response is logarithmic. Okay. Thank you, students.